This is how you calculate load factor in a leveled turn. First off, load factor is defined as lift divided by weight. It is a global measurement of stress. It's dimensionless because it's the ratio of two forces, but sometimes we refer to that ratio as G's instead of unit because of its relationship to gravity. If you weigh 200 pounds, that's at 1 G. At 2 G's, you'll weigh twice as much, or 400 pounds. On the scale, anyway. In straight and level flight, lift is equal to weight. And because lift divided by weight is 1, the load factor is 1. Things get a little more complicated in turning flight. And again, this is at level flight. Your lift vector is greater than weight because it has to provide the centripetal force for the turn as well as the apparent lift to counter weight. I'm going to point out a couple relationships to help us here. This angle of bank, theta, is the same as the angle between lift and apparent lift because they're congruent angles. Also, if you remember your trigonometry, lift cosine theta is equal to apparent weight. And what we're going to do is try to get this into terms of lift and weight. Note that apparent lift is equal to weight. And apparent lift, as we discussed, was lift times cosine theta. And that equals weight. Now all we have to do is divide both sides by weight. We get lift over weight. Divide by both sides by cosine theta. And then we end up with lift over weight equals 1 over cosine theta, which is load factor. Let's take a look at load factor for different angles of bank. So at 0 degrees bank, your load factor is 1. So you're just trimmed for level flight. At 15 degrees, it's 4% more. You're going to need a hint of back pressure. But I think this here is really the key takeaway. At 30 degrees of bank, your load factor is 1.15, or 15% more than normal. You're going to need to really consciously add some back pressure here. At 45, it's 1.41, so you're going to need some moderate back pressure or trim. And at 60 degrees bank, you're going to be load factor at 2 G's. And you're going to need some heavy back pressure or some aggressive trimming. That's it.